Alright, so I think this is a recording. Sometimes I struggle with these videos. I'd like to do these 12 problems, and I got online and found a website that had these, they used to call them algebra with pizzazz, that you solve the equations, but down at the bottom there'll be some kind of a punchline to this joke of what do you get when you cross a turtle with a porcupine. So the directions here tell us to define the answers and come down and cross out the letter, and then what remains will be our joke. Well, that was so small right there that table I copied and pasted it a little bit bigger right here, and I'm just going to bring this along with me to each problem as I do them, and we'll cross them out as we go. So let's take a look at this problem number 1. It's set up, we have a fraction equal to a fraction. That type of an equation is called a proportion, and one technique to solve this is to cross multiply. So I like to draw little guidelines, and on this software it's nice that it's even highlighted, and I'm going to multiply along that diagonal and then multiply along this diagonal. So if I multiply along the yellow diagonal, I have 5 times x, and if I multiply along the other diagonal, I have 4 times x plus 2. So now we have an equation that we've seen before. It's just a linear equation. The exponents on the x are 1, and step by step you want to get the x on one side and all the numbers on the other. So the first thing that you have here is a multiplication. On the right hand side you have 4 times this binomial. Well, when we have something that's called the distributive property that says that multiplication distributes over addition. So it allows us to say that we can multiply 4 times x and then go over the addition and multiply 4 times 2. And the sign is still going to be positive when we do that. So now we've almost got the variables on one side. If we subtract 4x from the right hand side of the equation, to balance the equation we have to subtract 4x from the left hand side. 5x's take away 4x's is just x. These cancel just like we wanted them to, and we have the x equals 8. So we come in here and see if we can find, let's move this down, if we can find 8, and here I see 8. So did it say to cross the letter above it? Yeah, surely it's above it. So I'm going to cross out this E because my answer there was 8. Now I'm going to take this box and copy it and bring it along to our next problem. So our next problem is the same idea, and in fact all of these are going to be the same idea. We're going to cross multiply. So we're going to multiply along one diagonal and multiply along the other diagonal, and take those products and set them equal to each other. So I have 3 times x along the yellow diagonal, and I have 2 times this binomial along the purple diagonal. So on the right hand side we have a binomial that's being multiplied by 2 by the distributive property. Multiplication distributes over subtraction, addition or subtraction. So what that means is I can take the first term 5 and I multiply it by 2, and then I can take the second term x and multiply it by 2. So now we have x's on both sides of the equation, and we want to get the x's on one side and the numbers on the other. So I'm going to collect my x's on the left. I'm going to add 2x to get rid of see, I'm doing the inverse operation. The inverse of subtracting 2x is to add 2x. And I'm going to do that to each side of the equation, and that's going to result in a new equation that has the same solution set as the original. And so here these guys cancel each other out, and now it's pretty easy to see by inspection that 5 times 2 is 10. But we have on the left hand side we have 2 factors. The factor of interest is x. To get rid of this other factor, I do the inverse operation. Instead of multiplying by 5, we divide by 5. And 5 divided by 5 is 1, so we have that x is equal to 2. And, that does not provide an extraneous solution. When I have a variable in a denominator, I have to make some type of note that If this technique had resulted in the answer 5, I'd have to throw it out because 5 minus 5 is 0 and you can't divide by 0. But we didn't have to worry about that with this problem. So let's come up to our let's shrink this up a little bit. And let's come back to our list. Make it bigger so I can see it. We're looking for the number 2 and we're going to scratch out that letter above 2. So here's a 2 over here. So if we scratch out the S there. So now this is our new box that you have at the bottom of your paper. And again, I'm going to shrink this up out of my way and see what we have here. So it's beginning to be really repetitive that we have a proportion, the claim that one fraction equals another, and the technique for solving that is to do a cross product. So we'll multiply along this diagonal, we'll multiply along this diagonal, and we'll set those products equal to each other. So we have 3 times 8, which is 24, and then we have 6 times this binomial, and we do need to have it in parentheses because both terms get multiplied by 6. So the distributive property allows us to multiply, distribute over the subtraction. So this first term x gets multiplied by 6, and the second term 3 gets multiplied by 6. So now I have the number on the left. I want to get this variable by itself, so I'm going to add 18 to both sides of this equation. So I get a resulting equation that is 42, and the negative 18 and positive 18 cancel each other out. And we've almost have the x by itself. The inverse operation of multiplication is division. So I need to divide both sides by 6 because 6 divided by 6 is 1. And 42 divided by 6 is 7. We didn't have a variable in the denominator, so we didn't have to worry about an extraneous solution. This is our answer. So let's shrink this up a little bit and look and see if we can find that answer in our table. And then scratch out the letter above it. So it looks like this 7 is appearing here. Now sometimes they'll have them appear more than once. I don't see 7 appearing more than once, so I'll scratch that out. So let's take this answer with us, this table, with us. Oh, excuse me, I had to cough there and I real quick had to hit the pause button. I did not want to cough in your ear. Alright, so again we have a fraction equal to a fraction. Sometimes they refer to fractions as ratios, and one technique to solve a proportion is to take the cross product, to cross multiply. So let's multiply along this diagonal and then multiply along this diagonal and set those products equal to each other. So along the purple diagonal, well, here let's do the yellow one. It doesn't matter which one we do first. Along the yellow diagonal we have 3 times x plus 4. And along the purple diagonal we have 5 times x. So with the distributive property, we have this number times this binomial that has 2 terms. And multiplication distributes over addition or subtraction. So it multiplies the first term, x, and we have 3x. It distributes over the addition and multiplies the second term, 3 times 4, and we have 12. So let's move the 3x to the other side. Let's cancel this by subtracting 3x here, and to balance the equation we'll subtract 3x here. The resulting equation is going to have the same solution set because we've balanced the equation. 5x's take away 3x's is 2x, and now to undo this multiplication, the inverse operation of multiplication is division, so we divide both sides by 2. 2 divided by 2 is 1, and we have that x equals 6. And we look up here, and x equals 0 would be the only value that I'd be afraid of because it would cause division by 0. Alright, so let's look at our table and see if we can't find 6 in our table and then scratch out the letter, and there it is, the very first number here, 6, and we can scratch that letter out according to the directions if I'm reading that right. I don't think there's another 6 in here, No. So let's take our answer, our table, and just continue working, right? So this is just practice, and sometimes that's what you need is repetition, practice solving these proportions. And the technique that I'm going to stick with, it's working for us pretty well, is to cross multiply. So if we multiply along the yellow diagonal here, we've got 2x times 3. Well, the 2 times 3, that product is 6x. And then along the purple diagonal, I have 5 times this binomial. And so now I need to distribute this 5 to both of these terms. Both of the terms inside the parentheses get multiplied by the number 5, and the justification for that is by the distributive property. And this multiplication distributes over the addition, and 5 times 1 is 5. Well, now if we subtract 5x from each side, we immediately have our answer. 6x's take away 5x is just 1x, and these guys cancel, and I didn't have a variable in the denominator, so I didn't have any restrictions. I didn't have to be afraid of any answers, and I'm looking for this answer in the table. So let's shrink this up and see if it should be in our table. Let's hope that it is, and we'll cross out the letter above it. So do you see a 5? There it is right there, and up above it, let's scratch out V. Alright, so let's take this table that has the values we've been crossing out, bring it to the next problem. So the expressions are becoming more complicated, but the idea is still the same. We have a fraction equal to a fraction. That kind of equation is called a proportion, and the technique to solve this is to cross multiply. So I like to draw these guidelines in there just to help me. So this 3 gets multiplied by this binomial x minus 7, and this 9 gets multiplied by this binomial 3 minus x. So both terms get multiplied by 3, and we have 3x minus 21, and both terms get multiplied by 9, so we have 27 minus 9x. Now we have a decision to make. Let's collect our variables on one side of the equation and our numbers on the other. I'm going to leave the 3x right where it is, and I'm going to add 9x to both sides, and that will get me my variables on the left-hand side. So now on the right-hand side, all I have is a number, and that's what this number that's by itself there, I want it to move to the other side. I want to add 21 to the left-hand side, and then add 21 to the right-hand side of this equation. Then this negative 21 and positive 21 cancel. My resulting equation, I have 3x's plus 9 more x's is 12x's. And on the right-hand side, we already said that these terms of the x cancel, the negative 9x and positive 9x. Well, if we add these two numbers together, we get 48. To get the x by itself, we have to undo this multiplication, and we have a property of equality that says if you divide the one side of the equation by some non-zero number, you have to divide the other side of the equation by a non-zero number. See, I can't divide both sides by 0. 12 divided by 12, that's 1, and I have x. 48 divided by 12, you can check it on the calculator, but that's 4. So now we're ready to look at our table and see if we can find the number 4, and the directions said cross out the letter above it, I believe, or at least I'm hoping. That's how I'm doing these so far. So, but we'll double check that direction again before we actually. All right, above the 4 here is an N, so I'm going to cross that out. Let's copy this and bring this table along with us to the next problem. Shrink it up and give us some room. See, I've crossed out 3, 4, 5, 6. I've crossed out 6 numbers, and I'm on problem 7, so I haven't lost anyone. Sometimes when I'm copying on this software, it doesn't copy all of it, so I want to make sure that it's crossing out the things that I'm canceling out. All right, so we have a fraction equal to a fraction. That's a proportion. We can cross multiply, so I draw diagonals. To cross multiply along this yellow diagonal is just 5 times x. And to multiply along the other purple diagonal is 4 times 30. Well, 4 times 3 is 12, and then times the 0, the 10, I get 120. So I need to divide both sides of this by 5 to undo this multiplication so that 5 divided by 5 is 1, and I just have x. Well, 120 divided by 5 is 24. Now, let's check on a calculator to make sure that I haven't made a silly arithmetic error. If I have 120 divided by 5, yeah, I got 24, okay? So, let's shrink this up. Pull our answers down, look for 24. There it is right there, and I don't see any other 24. So I'm going to cross out the letter above it, G. And I'm going to bring this along with me. So the excitement is building as to what the punchline is going to be, right? Alright, so again, I have a proportion. And again, to solve this proportion, I'm going to cross multiply. I'm going to multiply along this diagonal, and then I'm going to multiply along this diagonal. Along the purple diagonal, I have 3 times x minus 1. And along the yellow diagonal, I have 2 times the binomial 5x plus 2. If I distribute this 3 to both terms, both of these terms get multiplied by 3. I'll have 3 times x minus, well, 3 times 1. And here I'll have 2 times 5x, or 2 times 5 is 10, and then plus 2 times 2 is 4. So let's collect the x's on one side and the numbers on the other. I like to work towards positive values, so if I subtract 3x from the left-hand side, then I know that those are going to cancel and that 10x minus 3x is a positive value. It's 7x. Now, this 4, I need to move it to the other side, so I'm going to subtract negative 4 to cancel it, so I have to subtract 4 from this side. Negative 3 minus 4 is a negative 7. And to get the x by itself, the opposite of multiplying by 7 is to divide by 7. 7 divided by 7 is 1, so I just have 1x. And a negative 7 divided by a positive 7 is a negative 1. I didn't have any variables in my denominator, so I don't have to worry about this being extraneous. So let's check our table, see if we can find negative 1 in the table and cross out the letter above it. So on the top I don't see negative 1, and then down here, there we go. I see a negative 1 here, so I'm going to cross out h. So I'm going to bring my table with me. Shrink this up. And again, I have the claim that a fraction equals to a fraction. That equation is a proportion. And I'm going to cross multiply. That's the technique that we're using to solve proportions. And 9 times x is 9x. And 7 times 36 might be 252, but you know what? It's late enough and I'm not thinking straight. So let's multiply 7 times 36. Hey, 252. I'm surprised I have that. So if we divide both sides by 9, what do we get? Well, 9 divided by 9 is 1. This goes in there maybe 28 times. You know what? Again, I'm not going to trust myself. 252 divided by 9. Divided by 9. 28 times. I think that's an 8. Boy, I can't hardly see that. Yeah. Alright. So 28. So let's shrink this up and pull our answers down in this table and see if we can find 28 in the body of this table. Alright, so there it is. So let's cross out the letter above it there. So let's group this table together and copy it and bring it to the next problem. Shrink it up and take a look at this problem. Well, to solve this equation, to solve for x, again, it's a fraction equal to a fraction. They call that equation a proportion. So we multiply along one diagonal. We can take the cross product, and that's the technique we're using to solve these. So along this yellow diagonal, I have 5 times that binomial. And along the other diagonal, I have 1 times that binomial. Well, that's the easiest multiplication of all to do, because 1 times that is, whenever you multiply by 1, you get the identical thing back. They often call 1 the multiplicative identity. On the left-hand side, both terms in this binomial are being multiplied by 5. So we've got 5x, 5 times x, plus 5 times 2. Well, hey, that's 10. And that's equaling x minus 2. I can put the 1 there to help me visually not make any silly mistakes. Let's collect the x's on the left and the numbers on the right. So let's subtract 10 from both sides. That'll get the variable on the left by itself, the 5x. And, well, I did that too soon, didn't I? Let's move this at 1x to the other side. So let's subtract x from both sides. And now 5x's take away 1x is 4x's. And, well, the 1x minus 1x, the x's cancel, and I'm just left with a number. Negative 2 minus 10 is a negative 12. And to get the x by itself, we do the inverse of multiplication, which is division. And we divide by 4, and 4 divided by 4 is 1. And a negative 12 divided by a positive 4 is negative 3. I was only afraid I would only throw out the number 2 if it were a solution. 2 minus 2 would give me a 0 in the denominator. So the restriction, before I even started this, I could have said, hey, if we get x equals 2, we're going to throw it out. But we didn't. So let's pull this table down and see if we can find 2 in the body of the table, and then cross out the letter above it. So along here, I've already crossed out a 2. Is there any other 2's? No. I'm surprised that we had a... Oh, look, x isn't equal to 2. That's what I wanted to avoid. The answer I'm looking for is negative 3. See, it is getting late. So here's a negative 3, and above negative 3 is the letter n, and I'm going to cross that out. And I don't see any other negative 3's. Boy, that would not be fun if I make a silly mistake on this for you guys, would it? Alright. I think we've only got 2 more to do, so we're just about done. Alright, we have a fraction equal to a fraction. That's a proportion. The technique for solving a proportion is to cross multiply. If we multiply along the yellow diagonal, we have 5 times this binomial, 2x plus 6. And if we multiply along the purple diagonal, we have 4 times x. So if we use the distributive property, the first term, it gets multiplied by 5. So 5 times 2 is 10, and we get 10x. And then the second term, 5 times 6, well, hey, that's 30. So let's move that 30 to the other side by subtracting 30 from each side. And then that's going to cancel there. So now let's get the letters on the left by subtracting 4x from each side. And the resulting equation, well, 10x's take away 4x's is 6x. And 4x's take away 4x's, those went away. So we have negative 30. To undo this multiplication, we do division. And 6 divided by 6 is 1 on the left. So we often say that these factors cancel, but really they just divide to 1. And a negative 30 divided by a positive 6 is a negative 5. So the only number that I'd be concerned about would be 0, and I didn't get that as a solution. So let's shrink this up and look at our table and see if we can't find a negative 5. So here's a negative 5, and above it, I'm going to cross out r. Alright, so now let's take this answer and move it to our last problem here, or what I think is the last problem. And again, it's a proportion. So the technique to solve this proportion is to cross multiply. So along the purple diagonal, 2 times 1 is just 2. And along the yellow diagonal, we have 2 times the quantity 3 plus x. So we use the distributive property. Both terms in this binomial get multiplied by 2. We've got 2 times 3, which is 6. And then 2 times x, which we just write as 2x. So let's subtract 6 from both sides. And then that way, we're a step closer to getting this x by itself. 2 minus 6 is a negative 4. So now we've got 2 times x, and we want to undo that multiplication. We want to just have the x. So they say the inverse of multiplication is division. We divide both sides by a positive 2. And 2 divided by 2 is positive 1. You can put the 1 there if you want, but it's not necessarily needed. But a negative 4 divided by a positive 2, that is negative 2. Let's look and see if we can find negative 2 in our table and then cross it out. So here's a negative 2. Let's cross out the letter above it. So I think that's done. So let's take our table back to the original joke and see if we've got it, if we can read the punchline. So let's paste our answer. Oh wait, that came off of there. So I need to know what that crossed out, right? So let's group this together. Let's get rid of this guy. Alright. What do you get when you cross a turtle with a porcupine? S-L-O-W, slow. And then P-O-K-E, slowpoke. You get a slowpoke. That's kind of funny. Turtle slow and the porcupine will poke you. Ha ha! We did it. Slowpoke. Alright. So I know it's corny, but hey, I hope you enjoyed it. I'll talk to you later.